For section 3.3, simplifying square roots, you are going to simplify square roots that are not perfect squares. When we do this, we're going to attend to precision because we have a lot of numbers that we're going to be working with and we have steps that we're going to have to go through. So we're going to have to make sure we're being very precise, we're being careful, we're being exact in our work that we're doing. Now, when I talk about perfect square roots that are not perfect squares, I'm talking about something like square root of 63. So square root of 63 is not a perfect square. And so this does not come out to a whole number. Now, if you think way back to the beginning of the year, when we had something like square root of 63, we said that it was irrational. So that means that if you were to calculate this, it would be a decimal that goes on forever and does not repeat. So it cannot be written as a fraction. It cannot be written as a decimal that ends or repeats. Then if you think a little bit past that, we estimated square roots. So we did this where we said, well, 63 is between 49 and 64. So square root of 63 is between 7 and 8, and then we went through that whole process. That was estimating. That did not get us an exact answer. It was an answer that was basically rounded to the nearest hundred. What we're doing today is we're simplifying square root of 63. So we cannot write this as a decimal because that's impossible since the decimal goes on forever with no repeating. What we can do is we can write it with a square root still, but we can write it so that the numbers are smaller. So we'll have numbers that are smaller than 63. So what we're doing today, once again, simplifying square roots that are not perfect squares, all we're doing is this is simply just an advanced version of finding square roots of numbers. When we find square roots of numbers, we already know how to do that with perfect squares. We know our perfect squares. If you don't know your perfect squares, then you need to take some time on your own to memorize those, because at this point, you should know those. So the perfect squares would be something like square root of 36, that's equal to 6, or square root of 100, which is equal to 10. We know how to do that. So what do we do if it's not a perfect square? Well, we have some steps that we're going to have to go through. So if our radical is just another name for square root, if it's not a perfect square, we have 3 things we need to do. The first thing is we need to write out a factor tree. So I'm going to use square root of 63, and we're going to go through each step one at a time. So square root of 63, when I'm doing a factor tree, I'm going to look at the number inside the square root, and I'm going to think to myself, what are the factors of 63? I can't write just any 2 factors. It needs to be 2 factors that multiply to 63. I don't want to use 1 and 63. If that's my only option, that means that my number is prime and I cannot make a factor tree from here. I want any numbers other than 1 in that number. So for this one, that would be 9 and 7. 9 times 7 is 63, so 63 breaks off to 9 and 7. Now from there, I want to break these down as far as I can. So 9, well, I can do 3 times 3. So I'm going to break 9 down to 3 and 3. When I go through this, once I cannot break a number down anymore, so for instance 3, the only factors of 3 are 1 and 3, and I'm not going to use those. Once I get to that point, I'm going to put a dot below it. And I need you to do the same thing. So 3s are prime, 7's also prime. So that's all I can do with this. That's all I'm doing on this first step. Next, my second step, I'm going to circle the pairs and box the singles. Circle the pairs and box the singles. When I do this, I'm only working with those numbers that I put the dots by. So this is why it's really important that you put the dots so that you know what you're looking at. So in this example over here, I'm not looking at the 9 because the 9 broke up into the 3 and 3. I'm only looking at the 3, 3, and 7. So when it says circle the pairs, I'm only looking at pairs. So I'm only looking at groups of 2. And it has to be the same number. So I have 2 3s, so that's a pair. 7 is by itself, so I'm going to box it. That's all I'm doing in the second step. Now going on to the third step, this is where I really need to attend to precision. This is where I need to be really careful with what I'm doing because I'm going to rewrite this as a different radical. I'm going to rewrite it as a different square root. When I do this, I have 2 different things that I'm going to be focusing on. The first one is that the pairs move out. When they move out, they become 1. And I'll explain that in a little bit more detail in just a moment. The second thing, so the pairs move out, and then the singles, so those single numbers that are boxed in, stay in. So I want you to picture a scenario where, of course, nobody dates in middle school because you're too young for that. But once you go to high school, people start dating. And so imagine that Friday in high school is date night. So on Friday nights, all the couples go out on a date, and all the single people then would stay home. So that's what we're going to do here. Our numbers, our groups of numbers are going to go out, and they're going to go on one date, and our singles are going to stay in. So for this one here, I have one pair of numbers. So this is kind of like a couple that goes out on a date. And so they go out, but they only go out on one date. So I'm only going to write 1, 3. Now I need you to picture that square root sign as a house. The 7 is single, so it stays at the house. It stays in. What I just did here, 3 times the square root of 7, or 3 radical 7, or to shorten that even more, you can say 3 rad 7, is the same thing as square root of 63. If you were to calculate those two things, they would be the exact same number. What we did is we simplified square root of 63. So we still have that square root sign in there, but we have smaller numbers that we're looking at now. This right here is all that we're doing today in this section. Now, one thing I want you to notice is, first, remember when you have a number and a variable right next to each other, that's multiplication. Well, when you have a number and a symbol, like a square root sign right next to each other, that's also multiplication. So right here, this is the same thing as 3 times the square root of 7. That is all I'm doing in this section. So let's go ahead and go through some examples. First, I have the square root of 48. So the first thing I need to do is make my factor tree. I have multiple options for 48. 2 times 24 is equal to 48. 3 times 16 is equal to 48. 4 times 12, 6 times 8. So I can pick any of those because no matter what factors I choose, it's going to work out and you're going to end up with the same numbers at the end. So here I'm going to choose 6 and 8. So I'm just going to work left to right now, and I'm going to simplify my numbers left to right. So I'm starting with 6. Well, my two factors of 6 are 2 and 3, and those are prime, so I'm going to put a dot beneath them. Then I have 8. Well, 8 is 4 and 2, and now left to right I'm going to work with 4. 4 is 2 and 2, and then those are prime, so I put a dot, and same with that last 2. So now I have 4 2s and 1 3. So I need to circle my pairs. Even though I have multiple 4s, I have more than I have multiple 2s, I have more than 2 2s, I'm only circling 2 at a time. So I have a pair right here that's pretty easy to see. And now I have a 2, a 3, and a 2 left. Well, these 2s, even though they're not right next to each other, they're still a pair. So I'm going to just connect them with a little line to make sure I know that. All I have left now out of the numbers that have dots beneath them is the 3, and so that's going to be a single. Now my next step is to rewrite this. So I need to take the pairs and they go out on a date. So first I'm going to take this pair here. My 2s are going to go out on a date, so I have a 2. Then I'm going to take my pairs here that are connected with that line, and they're going to go out on a date. And all I have left is my 3 that's left at home. Remember that this is multiplication, so this is actually 2 times 2 times rad 3, which is equal to 4 rad 3. And that is my final answer. Going on to the next problem. Negative square root of 96. My first thing that I'm going to do is my factor tree. I have a couple options here. I know that 12 times 8 is 96, so I'm going to do that one. Working left to right, I know 12 is 2 times 6. 2 is done. Now 6 is 2 times 3, so my 2 and my 3 are done. Now I need to go back over to 8. 8 is 4 times 2. 4 is 2 times 2, so my 2's are done, and my final 2 is done. So I have 5 2's and a 3. I need to circle my pairs. Well, I have a pair right here. I have a pair right here. And I have a 3 and I have a 2 left. So even though I have pairs of 2, I have 1 extra 2 left over. So it's going to be a single. And my 3 is a single as well. So now when I rewrite this, I have my first pair, 2 times 2. So I have 1, 2 that I put out here. And I have my second pair. Remember, this is multiplication. And then I have my singles inside the house. Now, before I go any further, I want you to notice that I worked through this and I didn't even acknowledge the fact that there is a negative sign here. That's okay, because when you're doing the first 2 steps, which are the factor tree and then the circles and boxes, you're only focusing on the number under that square root sign. But once we get to the bottom and we rewrite it, we need to pay attention to what's inside of that, or what's in front of that square root sign. I have a negative in front of it, so I need to have a negative in front of all of this. So this is equal to negative 4 rad 6. Just like I multiply my numbers outside of the square root, I also have to multiply the numbers inside of the square root. And that's my final answer. Go ahead and pause this video and work this next problem out on your own. Once you have it worked out, play the video and I will work through it. The first thing I'm going to do with square root of 72 is my factor tree. So I know that 72, I have 9 times 8. Then my 9 breaks off into 3 and 3. And my 8 breaks off into 2 and 4. My 2's done. My 4 is 2 and 2. So now I'm going to circle my pairs. So I have a pair of 3's. I have a pair of 2's. And then I have a 2 all alone. Remember that as I'm doing this, I'm ignoring all of these numbers that I broke down into smaller numbers. I don't need to pay any attention to those now. So now I need to take my numbers out. So I'm going to take my 3's out, and I'm going to take my 2's out, and then I have my single 2 alone inside that square root sign. I can multiply my 3 and 2, so this is 6 rad 2. That's my final answer. Continuing on, I'm going to go down to D. D is a little different. There's a fraction here. There's a lot going on. Well, when there's a square root sign that goes over the whole fraction, that means that the numerator is you take the square root of the numerator and you take the square root of the denominator. And now we're just going to take it one piece at a time. What is the square root of 81? Well, 81 is a perfect square. So I know that the square root of 81 is 9. And the square root of 121, well, 121 is also a perfect square. So I know the square root of 121 is 11. So now I have a fraction and no square root signs. And I need to look at this and ask myself, can I simplify this fraction? Well, there's not a number that I can divide out of both 9 and 11. So this is my final answer. All right, going on to E, I have negative 3 rad 12. So once again, I'm not paying any attention to the number in front of the square root sign for now. My first step is only to do a factor tree of the number inside the square root. So 12 divides to 4 and 3, or 4 and 3 are factors of 12. 4 breaks into 2 and 2. My 2's are done and my 3's done. Now I need to circle my pairs and box my single. And now that I'm rewriting, I need to pay attention to what's in front of that square root sign. So I have a negative 3 out front because that's in front of the square root sign. And then my pairs, my 2 and my 2, are outside of the square root sign. And then I have that last 3 under that square root sign. And I just need to multiply this now. Negative 3 times 2 is negative 6 rad 3. That's my final answer. We have just one more problem left. Go ahead, once again, pause this video and work this last one out on your own. Once you're done, play the video, and I will walk you through it as you need and double check your answer. So once again, you're not paying any attention to the number in front of the square root sign. For now, we're doing a factor tree for 45. 45, two factors of that are 5 and 9. Well, 5 doesn't factor down, so I'm actually done with that now. My 9 factors down to 3 times 3, and now those are done. Now I need to circle my pairs. I need to box my single. And now that I'm rewriting, I need to pay attention to my number in front of the square root sign. So I have that 5 in front of the square root sign. My pairs, my 3 goes out, and I'm left with a 5 inside. And now when I multiply this out, I get 15 rad 5 as my final answer. You are good to go now to finish to do the 3.3 homework assignment. And as always, if you have any questions, still definitely come talk to me and come ask me.